Yes, good morning to everyone. Yes, good morning to everyone. Sir, am I audible in both classes and screens are visible? Okay.
Yes, sir. It's
Okay,
okay,
ma'am,
sir.
sir. Thank you. Okay, ma'am. Thank you. Fine. Good morning, students. Today we are day 9. Fine. In the previous session, we have discussed how to program the keypad. Okay. So different algorithms we have discussed. Fine. Do you people understand it? Yes or no? Yes, fine. Whether I need to repeat the thing what we done in the last session? Or else it is clear. Okay, fine. So shall I move to the next thing? Shall I move to the next thing? Yes. Okay, fine. Wait a minute. I'll skip these things. This and all we have seen in the previous session. Okay, fine. In today's class, we are going to discuss about the multiplex 7-segment display. Okay. Can you people or do you people earlier worked on this multiplex 7-segment display? Have you worked on this? Yes or no? Kindly respond. Is my voice is clear in both classes? Yes. Okay, you have worked. Fine. What we have to do actually in the case of multiplex 7-segment, what we have to do? Actually, the concept I have told you in the theory class while teaching the topic 8 to 7-9. Fine. Have you people worked on it? That means using Arduino microcontroller, Arduino board. Have you people worked on it? Either in Tinkercad or real hardware? No. Fine. So today we are going to know how to interface this particular 7-segment display, multiplex 7-segment display with a microcontroller. Then how to program it. Fine. The concept is going to be very simple. In the previous session, we have discussed about the keypad. Fine. So in that, which method we followed to identify the key press? We scanned the one by one line. We have read the row line, and from that we can understand which key got. Okay, in that hex keypad or matrix keypad, which one of the thing must be running always? Which process must be getting done always? If you want to read a matrix keypad, which process has to be takes place again and again, so that you can get the key value at the instant when a user presses key. Yes, very good, scanning. Fine. The same process we are going to do here also. Fine. Okay. Very well. There are two types of 7-segment display we are having. What are the two types? There are two types of 7-segment display we are having. What are the two types? In other words, I can say two configuration. Yes, common anode configuration. What about the other one? Yes, common cathode. Fine. Very good. Okay, fine. Okay, very good. Fine. Here, what I have taken is common cathode. In this particular diagram, what we have taken is common cathode. Fine. In this particular diagram, we have taken common cathode as an example. Fine. See, you are having 4 digits. Okay, 4 digits which can be displayed on each 7-segment. Fine. So this 4 digit combinedly we call it as multiplex 7-segment display. Fine. In the case of multiplex 7-segment display, we will be having a common data line. We will be having a common 8-bit data line to read the data into the 7-segment display. We are having 8 LEDs, means 7 segments plus the decimal point. Fine. Totally, we are having 8 LEDs in each 7 segment. Here, what we have done is we have taken the A segment from all the 7 segment LED and connected to A. Is the thing is clear? See, this we call it as bus representation. Group of signal means we can call it as bus. That means all the 8 lines A, B, C, D, E, F from the individual 7 segment are tied together and taken as 8 line as A, B, C, D, E, F, G and DP. Is it clear to everyone? Is it clear to everyone? Yes. Okay. I have told you it is common cathode configuration. It is common cathode configuration. All the 7 segment LEDs here are common cathode configuration. You can see the common pin KK. That means 2 pins we are having. Both are common cathode terminal. Fine. Where we have to connect the cathode terminal? Where we have to connect the cathode terminal? Yes. Where we have to connect the cathode terminal? Yes, very good, ground. Okay, very good, ground. Fine. So in this particular thing, you can see we are using 2 ports. Okay, one port for data, fine, for writing the data. Another port for selecting the digit control, segment control. We are splitting the things into 2. Okay, one is segment control, the another one is digit control. Fine. In the digit control, you can able to see one thing. Fine. You have the one pin. It is a ground pin. Fine. We have used a transistor on-off configuration. That means if the port pin is high, the transistor will get on, and this collector terminal is almost connected to the emitter. That means it is connected to ground. Fine. That means what? To enable the digit, we have to turn on this port transistor individually. Which digit I want to display, I have to enable that particular digit alone. Fine. Is it clear? Is it clear? Yes. For example, if I want to display some number 1, 2, 3, 4 on the display, fine, what I have to do is first initially I have to turn off all the digits. Please carefully watch what are the logic I am telling. When writing the program, we are going to apply it. Fine. The very step what we have to do, we have to disable all the segments. So what you have to write here? Yes, what you have to write from the 4 pins? You consider this as D3, D2, D1, D0. Simply like that. What about the data bit you have to write? I must turn off all the digits of the 7 segment, multiplex 7 segment. Yes, what we have to do? It should not get connected to ground. That means collector to emitter part should not get turned down. What we have to do? In this case, all the transistor must be in off condition, right? Am I right? Initially, you have to do this. Please listen. Initially, you have to do this. For this, what about the data you have to write? 4-bit data. Kindly type in chat. Students, kindly respond. Am I audible? See, I want to disable all the 4 7-segment display so that its common terminal must not be connected to ground. If it is connected to ground, then only it will get turned on. Yes, when this will get connected to ground, if you are writing logic 1 to the pins 1, 2, 3 and 4, okay, the transistor will get turned on and the cathode terminal of this particular 7 segment, individual 7 segment, get connected to ground. Yes, very good, Logus Nega. We have to write 4 zeros. Okay, kindly respond in 4-bit manner. Okay. So first digit So now we have disabled. Now we have disabled all the things. Yes, is it clear? Is it clear? This is the first step you have to do. Initially, the display should not show anything. All the things must be clear. So to clear the display, you have to disable all the digits. Is the first step is clear to everyone? Yes? Yes or no? Students, kindly reply. Yes, okay, fine. So next what we have to do is the digit in this position D1. Okay, here it is D1. If I want to display the number 1, what we have to do? Please carefully listen. What we have to do? We have to keep the data, 7-segment data, okay, for common cathode configuration in this 8-bit line. Okay, are you able to understand what I am saying? Now, if I want to display the number like this, for example, 1, 2, 3, 4. Okay, if I want to display a number like this, 1, 2, 3, 4, I am typing in chat. Please kindly refer it. Yes, if I want to display a number like this, what you have to do? First, you have to consider the first number. Find 1. So the 7-segment code for 1 for the common cathode 7-segment LED, we have to write. Whether it will appear in the first segment, first digit, yes or no, we have to keep the data first. Okay, first we have to make all the digits disable. Then what I am doing, to the first digit, which data I have to send, I am keeping it. Fine. Whether it will appear or not. Whether it will appear or not. Yes. Whether it will appear. Yes, we need to turn on the first transistor for enabling this particular 7-segment display. Yes. Is it clear now? For this purpose, which data you people have to write? Which data you people have to write? Yes, we need to turn on transistor. Yes, 1000. Very good, super. Fine. So now what will happen? The digit 1 will appear on the screen. Okay, fine. After a small delay, it might be some 1 millisecond to 10 millisecond. Fine. We have to refer the data sheet of the particular 7-segment LED. Okay. What about the turn on time? Okay. What about the response time of that particular LED? Fine. Approximately we can go for 1 millisecond to 10 millisecond. Fine. Generally for key debouncing we use some timing. Na? The same timing you can use it here also. Yes, is it clear now? That means the digit 1 appears for some time. Fine. After that what I have to do? Again I have to disable all the digits. Again I have to disable all the digits. So what you have to write on the digit port? Yes, what you have to write on the digit port now? Yes, very good. So first digit appear and disappear. Fine. It happens in the timing of milliseconds. Okay. It is happening with the time of milliseconds. It's not happening for seconds. In the program, it happens. It executes in a microsecond timing itself. So what I am doing, I am waiting for some time by having some delay. Fine. When we are doing simulation, we no need to go for the delay option. Fine. Because our simulator is running very slow, but to do real-time application, you have to introduce a delay. Fine. So after the delay, what I have to do? You people now tell me. Yes. After this, what I have to do? Next digit. Yes, next digit. D2, in position D2, I have to write the data for displaying the number 2. Correct? So data portal penna data. Yes, for next digit, we have to enable the digit like this. Before that, you should keep the data. Keep the data, enable, disable. Okay. Again, I repeat, disable all the digits. First step. Second step, put the data for digit 1, enable the digit, wait for some time, disable it. Next, what you have to do? Keep the data for the second digit, enable the digit, wait for some time, disable. Similarly, you have to do for the third and the fourth digit. Fine. After you gone through the fourth digit, again you have to come to the first one. So this process has to be repeated again and again in a faster way. Is the thing is clear? So this is the concept we are using for multiplex sound. Yes. Is it clear to everyone? Yes. Yes. Okay. Fine. Fine. So without this concept also I can able to display the numbers. Without this concept also I can able to display the numbers. But how many port pins I have to use? But how many port pins I have to go for? Interfacing 4 7-segment display to a microcontroller without this multiplexing concept, how many pins we need? To interface each 7-segment, we need 8 pins. So for 4 digit, how many pins totally we need? Yes, very good, 32 pin. All the 4 pins we have to sacrifice for interfacing this itself. Okay. What about the number of pins now required? What about the number of pins now required? Yes, 8 pins for data and 4 pins for digit control. Okay. So segment control, for segment data we need 8 pin and control the digits we need 4 pins. So with 12 pins we can finish it up. Okay. Can you tell me if I go for 8 digit, what is the maximum number of pins I required? If I go for 8 digit multiplex 7-segment display, maximum how many pins are required? Yes. Students, if I go for 8 digit, what about the number of pins I require? 4 digit mean 8 plus 4. What about 8 digit? Is it 64 and Surya? If you are using single, I mean without multiplexing concept, if you are going in, you need 64 pins. Okay. Now I am asking with multiplexing. Logus Nega, kindly check your answer. So 8 pin for data, that's fixer. I think Logus Nega, you are doubling when I am saying 8 digit. It's not like that. For data, always 8 pin. For individual digits, you should have 1 pin. Without multiplexing, same 12 pin. How it is possible, Antony Surya? Yes, very good, lovely. We need 16 pins. So 8 pins for segment and 8 pins for selecting the digits. Is the thing is clear to everyone? Is the thing is clear to everyone? Yes, is the thing is clear to everyone? Yes, okay. So what about the number of digits we are going? 8 plus the number, that's it. Okay. I will type one IC number. Kindly you people make a note of it and just search it on Google. Okay. Max 7219. Okay, Max 7219. Kindly check about this IC later point of time. I don't know you people will believe or not. We can able to program 8-digit multiplex 7-segment display with just 2 pins. Please understand, underline. With only 2 pins, we can able to handle 8-digit multiplex 7-segment display using this particular IC, Max 721N. Okay. Okay. So how that is possible? You people search it off. So in the next class, you people can say. So what about that IC? Which kind of protocol it is using? Definitely not parallel transfer. That's a sure thing. When I am going for parallel data transfer, definitely I need 16 pins for 8-digit multiplex 7-segment display. Okay, so there it used some serial communication only. Kindly you identify which type of serial communication it is following. Okay, just go through it. Fine. Okay, now you can see. Yes, is it clear now? Like this only you have to do. Keep the data, wait for some time, disable, next, like this. Is it clear to everyone, students? So step மட்டும் நல்லா note பண்ணிக்கோங்க. Disable all the digit, keep first digit, enable, wait for some time, disable, again second digit, enable, disable, third digit, enable, disable, fourth digit, enable, disable. Again you continue from the beginning. This process has to be put into the loop. Suppose if you come out of the loop, you can't display anything. Fine. It's a challenging thing when you are going for multiplex 7-segment display in your project, so that it should be continuously monitored. Yes, it should be continuously scanning all the time. Fine. For avoiding this and all only, we are going for 8279 or max 7219 such ICs. Fine. Okay, now we can write the program. Not only first program. So we have to write an embedded C program to display 2021 in multiplex 7-segment display whose data pins segment lines at P1, okay, and the digit selection pins at P0. Yes, is it clear? Is the problem statement is clear to everyone? How I am connecting segment lines or data lines? I am going to connect to port 1, and digit selection line I am going to connect to port 0. So port 1 I have to write the 7-segment code, and port 0 I have to make use of it to select the digits. Is it clear to everyone? Okay, fine. Okay, see, you should not think like this. Anode, cathode. In the case of 7-segment, we didn't use any driver. Of course we have to use it, but we didn't use it. Fine. You should not think like this. Digital select common cathode dana sir, appo zero dana eludano. You should not think like that. Yes, is it clear to everyone? If you turn on the transistor, it will connect to the cathode. Sorry, the cathode will get connected to ground. That is the configuration we are using. That we call it as digit driver. So in the transistor mode, this we call it as digit driver. Similarly, you can connect VCC to the segment using 8 transistors individually. That we call it as segment driver. Okay, that we call it as segment driver. I hope it is clear to everyone. Yes, shall we proceed with the programming? Yes, okay, fine. So now I am going to present my entire screen. Wait for some time. Wait a minute. Yes, is my screen is visible in first classroom? Now I am going to present in my second class. Yes, the entire screen I am going to present in the second class. Okay, so now I am going to open the software. See, if you are able to program this multiplex 7-segment display, it's very easy to program dot matrix display. Okay, so after this we are going dot matrix display only. Fine. Okay, now I am going to close the project. I can create some new project. Wait a minute. Okay, project, new project name is multiplex 7 segment. Project directory I am creating. It's not opening. Wait a minute. Wait a minute. I hope it will work in full screen mode. Wait. Yes, here I have the option. Full screen mode it will work. New multiplex 7 segment. Okay, so this is the name of the project. No, it's not working. Wait a minute. Okay, creating a file multiplex. I have to create a new folder. Wait a minute. Otherwise, the file will get scattered into that documents. New folder. So for this folder also, I am going to use the same name. Okay. Okay. Yes, I have created the file. Click on OK. So now I have to save this untitled file as a C naming. So we can name it C multiplex 7 C. That's very important. Yes. Okay. Wait a minute. Not able to see your chat. Okay. Fine. So now what about the first line of the program we have to write? Always. About the first line of the program we have to write always. Yes, we have to input the header file. Very good. We have to include the header file. Hash include AT89S52.h. Okay, then we have to define the ports. How we can use the naming? Port 0 and port 2, I think. What are the two ports I have told you? Sorry, port 1 and port 0. Port 1 for data. So how we can represent it? How we can represent it? As defined. You suggest me some name. You suggest me some naming. Okay, segment. Segment. Port 1. Right? As defined. Digit. Okay, digit. Port 0. Fine. So now I am going to start writing the program. Void main. Okay, first we people understand it's working. Okay, I'm not going to display any digit now. I'm going to just turn on all the segment in all the digits. So for this, what I have to do? First, I will give a hardware connection. Go to the virtual hardware tool. So you take multiplex LED display. Okay, so here we have port 0. Okay, port 0. It is for digit. In the left hand side, we are having 4 pins. This is for selecting the digit. Okay, the very first one belongs to the last digit. Yes, the very first one belongs to the last digit. Second one belongs to this. Third one belongs to this. Then the fourth one belongs to the first display. Fine. So here I am going to write it as, here I am going to select the pin as third pin. 3210 I am selecting. From the first digit, 3210. Yes, that's it. Coming to the data, I have to use port 1. If in port 1 we have to use pin number 7. Okay, 0 we will use generally, correct? 0, 1, 2, 3, 4, 5, 6, 7. Or else you can change the pattern as you require. Okay. So far we have used the 7 code from LSB equal to A and MSB equal to D. Correct? So on the format the follow pannirukkom. Fine. Okay. Now I want to enable all the digits. Here you can see this terminal, it is ground. Yes. This bubble symbol is there, na? That is equal to ground. That means if I write logic 1 on this particular pin, the ground will be enabled. Fine. So for this I have to choose which type of thing I have to go for. Common cathode. I have selected. Now what I have to do? Enable all the digits. That means what you have to do? Digit is equal to. Okay, before that I have to keep the data. Fine. So segment is equal to, as it is common cathode, LED, which logic I have to write so that the individual LED will go. Yes. Which logic we have to write so that all segments in the particular digit will glow. Any idea? Common cathode. That means cathode must be connected to ground. What about the segments? It must be connected to 5 volt. 5 volt means what? Logic 1. Yes. All 8 segment pins must be in logic 1. That means what about the data? 0xFF. Okay. So now what I am going to do is I am going to enable the lower 4 digit. I mean this 4 digit, lower 4 bit of this particular code. For this what I am going to write is digit is equal to digit and of no need, I think R, we can use R. Digit R with 0x 0f. I hope this line is clear to everyone because we have written many programs. Okay, if I do like this, the upper 4 bit will not get affected in that particular code. I can use it for some other purpose. Is the thing is clear to everyone? Okay, now while of 1. So you have to put always. That's it. Fine. So now what I am going to do is I am going to save the program. Yes, I am going to compile this. Okay, I don't segment instead of segment I use segment. Okay, I will change it. Somewhere I have to put like that. Yes, segment. That's fine. So click on the simulator, debug this file. Yes, that's it. Okay, now what I'm going to do is I'm going to turn on this particular thing. See, already all port pins are at logic FF only, so that it is glowing. So you won't see any changes in this. Okay, otherwise we will do one thing. We will display the number 7 we will display the number 7 in all the 7 segment display. Okay. Kindly you people tell me what about the bit pattern I have to follow. Fine. For this particular 7 segment code, you kindly assume this BPF. Wait a minute, I'm typing in chat. In this fashion, I have connected. Okay. Yes, kindly refer this. What I am typing in chat, kindly refer this. So A segment must be at LSB. That's very important. Kindly tell me the data for that. Identify and tell me the data. I want to make the segment A, B, C to glow. All others should get turned off. What about the data I have to write? In the segment port, what I have to write? Yes, kindly respond. What data I should write in the segment? Yes, 0807. So that you people understand. The initial one, all ports are with logic 1, so that it is glowing all digits. Okay. So now it will display only 7. Okay. Fortunately for displaying the number 7, the 7 segment code is also 7. Okay. Don't think if I write the number directly, it will display there. Okay. You have to find the 7 segment code. Okay. What you people typed is correct only. We will run the program now. Fine. Yes. Wait a minute, it is executing. After 800 microsecond only, this will change. Yes? Is it working or not? Yes? Is it displaying 7 in all the segment? To display the same number in all the digits, you just keep the data for the number you want to display, then enable all the digits. That's it. Is it clear to everyone? Yes. Okay, fine. Fine. Now you people help me to find out the 7 segment code for 2. I want the 7 segment code for the following digits. Wait a minute. 2, 0, 1. Because I want to display 2021. Correct? 2021. For this, you people tell me the 7 segment code. What about the 7 segment code for 2 for this configuration? Kindly help me out. So now initially what I am going to do is, okay. So initially what I am going to do is, I am going to disable. I am going to disable the data or digits you can disable. Wait a minute. Fine. Okay, I want the 7 segment code for 2, 1 and 0. Segment equal to 0x00. That means all the segments I am writing logic 0. Definitely it won't work. Fine. Similarly, all the digits I have to make 0. So for making 0, what you have to do? You have to perform AND operation. Okay. So initially what I did, I have disabled the digits F0. I'm ANDing with the port value. That means the port value lower 4 bit must be 0. If I execute this particular line, please listen. If I execute this particular line, all the segment will get turned off. A minute. Please wait. It will get turned off. Yes? Okay. Is it clear? Initially, I have made all the digits clear. Fine. Now I want to display 2. Now I want to display 2. For this, you people kindly tell me the 7 segment code for 2. Yes. What about the 7 segment code for 5B? Wait a minute. 5B. So what I am going to do is segment equal to 0x5b. Okay. After I kept the data, what I have to do? I have to enable the first digit position. For this, which data I have to write? For this, which value I have to write into the digit selection port? Digit or with 0x 0. Which digit I have to enable? First digit. For enabling first digit, what about the 4-bit pattern I have to use? 1000. 1000 means 8. Is it clear? Is it clear or not? Yes. Okay. So after I have displayed, immediately what I am going to do is disable all the digits. That's it. So this process I have to repeat again and again for all the digits. Okay, first digit, it will be displayed. What about the 7 segment code for 0? Yes, what about the 7 segment code for 0? Kindly help me. Kindly help me out. Or else you can do one more thing. Already we have the 7 segment code for common anode configuration. You just complement and write the data. Both are going to be the same only. Fine. Okay, what about the 7 segment for 0? You people told C0 in the previous class. That means we have to put 4F. Am I right? Kindly check and tell me. To display the number 0, we have to put 4F. Yes or no? Yes, kindly help me so that we can understand the program and write. இல்லனா நான் எதுக்கு 5B போடுறேன் 4F எழுதுறேன்றது புரியாது. 3F. Okay, 3F. Yes, 3F is the correct thing, not 4F. Very good. 3F. Okay, now what I have to do here, instead of 08, what I should put? 08 க்கு பதிலா நான் என்ன போடணும்? Which value I should write here? To enable the second digit. Yes, very good. 04. Very good. Thank you. Okay. Similarly, I have to write for the next digit. So again, I have to display 2 only. I am using this. Only you people build the 7 segment code for all the numbers 0 to 9. Yes. So same 5B data I am writing into the segment port. What about the digit port value I should write to display in the third digit? What value I have to write? First you have written 8, then you have written 4, then what data? Yes, very good. 02. Yes, thank you. Fine. So what about the 7 segment code for 1? About the 7 segment code for 1? Zero 06. Okay, fine. Thank you. 06. What about the value I have to write here? What about the value I have to write here? Instead of 02, what I have to put? 01. That's it. Is the program is simple or difficult? Yes, simple only. Okay, fine. So now you will run the program. Wait a minute. File, save. But you have to understand the concept. You have to know what data I have to write and which pattern I have to use to select the digits. Okay, fine. Simulator. Now we can run it. Wait for some time. After 800 microsecond. Yes. Can you people see it? 2021. Yes or no? Yes, that's it. Okay. Okay. I will ask you one thing. If you want to change some other value to be displayed, what you have to do? Any idea? For example, if I want to display any one of your date of birth or something else, what I have to do? I have to change the program. Am I right or not? Yes, we have to change the segment values. That's very good and inspiration. Okay, fine. How I can write a function so that I can always write a 4-digit number onto it? It's very, very simple. Yes, how we can do it? Using looping concept, we can able to do. Fine. Using looping concept, we can able to do it. Fine. How it can be done? Okay, now I'm going to introduce. Now I'm going to introduce a new concept. Now I'm going to introduce a new concept that we call it as pointer. Okay. In embedded C, we are going to use pointer now. Wait a minute. Before that, I will start working in an array. So that might give you an idea how you can put it in a loop. Okay, fine. So kindly people help me to find the 7-segment code for all the numbers. 0 to 9 வரைக்கும் chatல type பண்ணுங்கப்பா. Meanwhile, I will tell you how to do this in a loop. Fine. So initially, I should have a pattern. Like the scanning, what we done in matrix keypad. Here also we are going to have a thing called pattern. So the initial pattern is going to be 0x80. Why it is 0x80? So it is 0x80. No, the cursor is not working. Wait for some time. Yes, now I can able to move. Okay, fine. Suddenly the cursor got stuck. Okay, fine. Okay, students. First, what I am going to do is initially this thing you have to do. See this and all you can write some simple function. Okay, clear display, clear display. You can write a function. If you get into the particular function, display should be clear. Yes, like that you can write different functions. Later you can write it. So as of now, I am using this. Fine. So I have to go for some variables to be declared. So character variable I am going to declare. I am going to do in a loop as I am having 4 digits. Okay. To select the individual digits, I need to change the pattern one after the another. So 4 sequences I need. So I am assigning a character variable. What name we can give? Can give it as seg. Okay. Yes. Otherwise, no need, no need. Wait a minute. We have to give the name dig. Yes, digit. So dig indicates we are going to use a variable digit for the for loop. Okay. Now what I am going to do is for dig equal to 0, digit less than 4, digit plus plus. So within this line, what I have to do? When first time the program is executing, at the point of time, I have to write 1000. Correct? So already it is available 1000. It's not 18, it's 08. Sorry, 08. Sorry, people, it's 08. So that the lower 4 bits are 1000. Yes. So here what I'm going to do is segment line is equal to segment of with 0x. Wait a minute. Segment or the pattern shifted to right hand side for big times. Is it clear? Sorry, digit. Sorry, students. This is for digit. So before I'm enabling or disabling the digits, what I should do? I have to keep the data. Fine. I am going to create an array 7 seg. So from that I have to take the data. Yes, how we can do it? Segment is equal to, okay, segment is equal to 7 seg of, okay, 7 seg of, wait a minute, 7 seg of, so in the I'm going to give the value, okay, for this we are going to write some function. Fine. Have you people find out the 7 code for all the numbers? Can you people type in chat? So I'm going to declare an array double _ 4 character variable 7 seg. Okay. So here I have to provide the values. Yes, can you tell me? Okay, 3F06 0x3F 0x06 0x5B 0x4F 0x6 0x6D yes 0x7D yes 0x07 0x7F then finally 0x6. That's it. Fine. Okay. So now what I am going to do is I have to use a pointer variable. I have told you to use a pointer variable. For this, what we have to do is display. Okay, display. Okay. Which number we can display? Any idea? Instead of 2021 or else 2021 itself we can display. You people suggest me. Yes? Okay, 2001. Okay, fine. 2001. Fine. So here you have to change. No need to change the entire code. Here you need to change. Okay. Right. You have to check whether this function is correct or not. Wait a minute. Just compile and verify. Statement. Okay, here digit, not digit. Okay, indirection to different type. Okay, I think here how to create an array itself. Fine. You can also use this particular pattern to create array. And what happens is the ASCII code for the numbers will get stored. Instead of putting flower bracket and giving the data directly, you can use this concept also. Okay, we'll check. Yes, you can use it like this. Later we will go for pointer concept. Now we can go with array itself. Right? Okay, what I have to do is, please carefully listen. Carefully listen. First, you have to take the data 2 from this array. How you have to take in this for loop? You can have some variable. You can have some variable val. Okay, val. You can have some variable val. Okay. After getting into this particular for loop, you have to get the data from the array. So val is equal to what you have to do? Display of big. Yes. So the first element in the array comes. What about the nature of the data? Whether it is a number or ASCII character. I am passing 2. Okay, but the ASCII value for 2 will come. Yes. Is it clear to everyone? The step puridungla. Val equal to display digit. Okay, if I write this line, the very first time dig equal to 0. So the 0th element in this particular array will come out. But it is a character array. Fine. So now within double quote, I have put the variables, I mean string. Okay. This means the ASCII value for the number 2 will come. It will not provide you the value 2 itself. Yes, what you have to do now? Yes, what you have to do now? How you can convert the ASCII value of a number to a number? Do you people know what about the ASCII value for 0? For 0, it is going to be 0x30 in hexadecimal. Okay. For 1, it is going to be 0x31. 0x31. Yes. Similarly, so and so. For 9, it is going to be 39. So how you can convert this ASCII value of the number into number itself? Any idea? Which concept we have to go for? Help me out. Yes, which concept I have to go for? Kindly reply in chat. I want to convert 31 to 1 or 32 to 2, 39 to 9. Whatever the second digit I am having, that only I want to take. So for this, which concept we can go? Help me out. If I give the value as 30, I should get 0. Yes, very good, Anthony Surya. The same thing here. Okay. Here also you can do that value and of 0x, 0f. That's it. Now what I have to pass? That value I have to pass. So from the array, 7-segment array, okay, it will take the corresponding 7-segment code for displaying that number. It will take. Yes. Now we have written the pattern for selecting the digit 0. I mean digit 1 for the very first time. Fine. Here it is digit 3, digit 2, digit 1, digit 0. Don't get confused. So this is our first digit always. Fine. 3 is our first digit always. Fine. Okay. Now we have to turn off the display. So for this we are going to use this line. Yes, this line we have to use. That's it. If I run this particular program, I will display 2001. Wait a minute, we will check it. Yes, it got compiled successfully. I'm going to run the program. Of course, this. Yes, it's not working properly because in this particular 7-segment display, you have one option, fade out interval. You keep it maximum 500. Yes, is it working now? See, it's not a real hardware, so they are having some provision, because if you are writing more number of lines, okay, when you are writing more number of lines, in between you will use many instructions. This simulator is designed in such a way that everything you have to configure. So இதுல என்னென்ன configuration இருக்குன்னு பாத்தீங்கன்னா, yes, you can change common anode or common cathode, then fade out interval. If you keep it 0, the moment you write, immediately it will get fade away. Fine. If I click on all fade out, it will get clear ones. Then it will continue. See, such provision they have given. Fine. If you are working with multiplex 7-segment display, keep the fade out interval time larger. I told you now. Otherwise, it will display some garbage value. Is it working now? Can you people tell some other number, 4-digit number? We will display it. I am not going to modify the program. I am going to just modify the display array. Yes. Can you people suggest any other value to be displayed? Okay, 1678. Wait a minute. First we will display 1678. Then we go with 6582. Have to stop the simulator. So instead of I am going to display 1678. Okay, now we can run the program. Yes, 1678. Is it appearing? Similarly, 6582 we can run. See, whatever the value you can change it. See, when you are initially writing a program, okay, what happens is the all ports are configured as input so that all things are at logic 1. So that you will be having some garbage value initially. Okay, but in the application, it won't happen like this. Okay, of course, if I want to say all digits will clearly visible in real-time application. Okay, as it is simulator, slightly fading. The color is slightly fading. Yes, 6582. Is it clear to all of you students? Is it clear to everyone? Yes. Yes. Okay, fine. Wait a minute. So now what I'm going to do is I'm going to use a pointer concept so that I will have a beautiful function. Okay. So this particular function we are going to implement when we are discussing working with LCD. Okay. Wait a minute. Here itself I will explain the concept that we can make use of it. If you know such things, you no need to bother about anything. Yes. Now what I am going to do is I am going to convert the first two line as display. I have to use this first two line as a function clear display. Wait a minute. Void clear display. Void. I'm not going to pass any values in this. So simply it is going to be like this. Okay. For the beginning, what you can do, you have to declare that function, otherwise it will show error. Void clear display. Void. That's it. Okay, next what I'm going to do is I'm going to write a function print display. Void print display. Okay, here what I'm going to do is I'm going to pass a pointer variable, okay, which is going to have character data type. Yes, it is similar to array, but here I am giving the address of the particular variable in a string. Okay, instead of going for array, you can go for this concept. Okay, fine. Here I have to make use of it. There I have told only the data type, pointer variable I am passing. So here what I have to do, I have to assign a variable for that. Print underscore display you people tell me a name here. Num variable. Yes, num number. Fine. I will pass some number, 4-digit number into that particular function. Okay. Coming into this, it will write the function. Wait a minute. So this portion I am going to take. This for loop portion I am going to take. So in that I have used dig and val as two variables. I have to initialize at the beginning of the function. A minute. Dig or val. I think here we have to do this thing. Fine. Okay. When I am passing a particular string, okay, the pointer variable points to the first character. Okay, the pointer variable points to the first character. So what I have to do? Val is equal to star num and of 0x 0m. Yes, the first character from the string, it is going to be a ASCII value, I am converting it into a number. Fine. After converting, I am writing into the segment with the segment 7-segment array register. Fine. So everything remains same. That's all about the program. No need to worry about it. But this is for one time. Please listen. This is for one time. If you write the program, print this means it will write for one time. Okay. So this has to be put into a loop for n number of times or infinite times, so that it will keep on displaying the number. Otherwise, what it will happen? Initially, it will display the number. After that, it won't show. Fine. Okay. Now what I'm going to do is this main program. It's going to be very simple now. So this part I'm going to erase. So this variable and all we can remove. So here what I have to do? Here display. That's clear display. The very beginning I'm clearing the display. Now what I have to do? Now what I have to do? Print display. Any number you can give, like your printf. So similar way only your printf statement works, but the difference is there it uses your monitor. Yes, your LCD display, right? Fine. Now I want to display the number 5678, for example, or 5798. Simply I am passing. That's it. You can do like this also. How we can do like this? Sometimes it will show the character. After that, it should turn off. Again, it should show the character. See, if you do it in real hardware, it is very, very beautiful. It seems very beautiful. You won't see that scanning process in real-time application. Actually, you can understand that scanning process just by keeping a mobile phone camera. If you keep a mobile phone camera to capture a picture of any 7-segment display, you can see that process. Scanning process will be visible somehow. Okay, fine. Okay, now what I am going to do is save the program, debug this one. Okay, now I am going to run the program. So it must display the number what I told. What about the number I have put? 5798. Wait a minute. No, it's, oh yes, sorry. I have forgot to increment the pointer. Sorry, in the program, I forgot to increment the program. Here I am not using the for loop, I am using the pointer concept. So pointer always points to the first number, right? We have to make it to increment. Yes, for that what we have to do? After taking the value star num plus plus. Okay, that pointer variable I have to increment. Otherwise, it will always point to the first number. So it seems only yes. Fine. Now I am going to run the program. I hope multiplex 7-segment display is clear to everyone. Yes. Now it's going to show 598. Yes, is it working now? See, now what about your program, main program? You just imagine whether your main program is difficult now to write. So that's all your main program. Yes, we are clearing the display and printing the value. See, such functions only you are using in the Arduino, right? LCD.print, yes, LCD.cursor, LCD.clear, many function you are having. Students, is the things are clear? Pointer means we are passing a string value into a function. In that particular function, if I'm assigning a pointer variable, so that can be used. Fine. At any point of time, you can change to any value, pointing to any value. Next value the point பண்ணனும் கிடையாது. You can point to some other value by using the pointer variable plus or minus. Is it clear to everyone? Yes? Okay, fine. Okay, the next task I will show you. What about the next task I will show you? If you are able to do this, you can build a digital clock. If you are able to do this, already we have studied timer programming. Okay, if you are able to understand and do this task, you people can create a digital clock. What I have to do? Write an embedded C program to display two-digit numbers from 0 to 99, one after the another, in a 2-digit multiplex 7-segment display. How we can do it? Yes. Here what we have to do? We have to display the number from 0 to 99. 0 to 99 you have to display one after the another in a regular interval. Can we do this? Or you people will try? Yes, we have to put loop and delay. But one thing we have to remember. Here I should not use the print display function. It is mainly meant for a string variable, pointer variable. When I am using a string operation, I can pass a pointer variable. Okay, so for this you have to use some loop and delay. Remember one thing. To display the number 0, 0, the loop has to be run for a few times. Okay, do you people try on your own? Shall I move to next device? Yes. Okay, fine. Regarding module 2, I am going to assign some 5 mini projects, you have to do. Okay, you have to use keypad, multiplex 7-segment display, LCD, dot matrix, whatever you are having the application. Okay, I will assign you some function. You have to do it as a project, simple project. For example, if I enter a correct password, 4-digit password, okay, I have to get 4 digits from the keypad. I have to compare it with a string. Yes, if it is matching, I have to turn on an LED. Like that, I will assign some 5 tasks. Okay, that 5 tasks is going to be split again as a project. Fine. Okay. Okay, shall I go to the next device? 8x8 dot matrix LED. Yes, shall we move into it? Okay, fine. Wait a minute. See, this is going to be a next interesting thing. If you understand multiplex 7-segment display, the same concept, dot matrix, it is going to work. But there we have to form the pixels. You people have to know how to form the pixels. Okay, better I can go with PowerPoint first. Then I will share my entire screen. Kindly note down this second program. I mean program 3. Okay, you people try on your own. Yes, it's presenting. Yes, am I audible in both classes? And presentation is visible? Yes, okay, thank you. Kindly note down this particular program 3. You people try on your own. Okay, for this we need only 2 digits. So 2 pins of the microcontroller, we can use it for the lower 2 positions. Yes, no need to go for all the digits. Fine, you can use only the lower 2 digits. That's enough. Fine. Now, 8x8 dot matrix display we are going to see. Fine. Generally 8x8 dot matrix, the name suggests the LEDs are arranged in the form of matrix. So how many LEDs we are having in a 8x8 dot matrix display? Yes. Yes, very good. 64 LEDs. Okay. Do you people know one thing? Do you people know one thing? In this particular display, variety of things are available. This kind of display, variety of things are available. Fine. Have you seen some text messages are moving in a railway station or some other shopping malls or somewhere else in simple roadside shop itself? Yes or no? The message will be scrolling. Even in your Mofassal bus, you can see. Yes, from where to where the bus is going. What about the path is going? Yes, okay. See, that are built with an array of LEDs connected together. Okay, so like this concept, right? But somehow different. There they use some different protocol, right? But the working of the thing, it's going to be same. Working of the thing, it's going to be same. Fine. There it is multiplex 7 segment display. Here it is 8x8 dot matrix display. Okay. So coming to this, we are having two types of device. Okay. One is column cathode, row anode. What about the other combination? There we simply say common anode, common cathode. What about here? Column cathode, row anode. Generally, people will say column cathode 8x8 dot matrix display. That means obviously row is going to be anode. Yes, is it clear now? How it can be connected in matrix form? LED matrix form la connect pandrathu. Yes. Anode of the, cathode of the first column LEDs are shorted together and taken as a single pin C0. Yes. Panlama. Then the second column LEDs are connected together and taken as C1. Cathode pins be common column wise. Then anode pins must be taken common regarding the row wise, like this. Yes. Is it clear to you people? Is it clear to you people? You can see those are connected to anode terminals of the LED in the row. The columns are connected to the cathode pin of the LED in the row. Sorry, in the column. Yes, that's about the construction. If you change this order, then it becomes column anode, row cathode. That's it. Here it is different. Column anode, row cathode. We are going to use the very first one only. Fine. So this only we are going to use. You can configure in any way. Fine. Now you people tell me what logic I have to write on row and column so that all LEDs will get glow. In row, what data I have to write? Obviously, we have to go for 2 8-bit port. 16 pins we need. Yes. 16 pins we need, obviously. Fine. One port for row, one port for column. Here, no need to worry about the masking and operation. Simply you can write the data. No issues. Can you tell me? Yes, what I have to write in the row and what I have to write in the column to make all the LEDs to glow. Row is going to be cathode and column is going to be anode. You just mention row data, column data. I want to tell you one more thing. Kindly take a screenshot. Why I am saying this? When you are using this particular dot matrix LED, you will be having 16 pins. The pins will not be in a correct order. Row taniya, column taniya, mix pin number 1, it is going to be row 5. Correct? Pin number 2, it is going to be row 7. Like that, it will scatter. Yes, kindly take a screenshot of this. Only Logos Nega typed the answer. FF. Logos Nega, we have to use two ports. Okay, one for row and another for column. What I have to write in the row port and what I have to write in the column port, so that all the LEDs will get glow initially. Yes, any idea? Yes, row equal to FF, column equal to 00. Very good. Very good. Very good. If you write this particular data, all the LEDs in the dot matrix will glow. Fine. You can able to control any LED to glow at a time. Fine. Either in a row or column. Please underline the word either in a row or column. Okay. A single row or single column, you can make it to glow at a time. Fine. You cannot able to display the data by writing simply row and column. Fine. Also, we have to go for scanning. What do you mean by scanning? What are all the LEDs should get glow when I am scanning column 1? Yes, that data you have to write it on row port and you have to select the column 2. Next, you have to go for column 2, column 3. Like that, you have to write the data. Now, the very first thing we can do, glow in the row, I have to write FF. In the column, I have to write 00 as Shivakumar told. Fine. Kindly note down one more point. Kindly note one more point. Here also you have to go for driver IC. Otherwise, your port pin may not be able to provide sufficient current. Why? That point I forgot to tell you in the previous slides itself. Why I have to go for transistors? Yes. See, if you are connecting a single port to the column and 8 pins to a row. For example, in column 1, I am writing logic 1 and the row line I am in column 1, I am writing 1 logic. I am saying common cathode. Yes, 0 logic. In the rows, I have to write 1 logic. If I write 1 logic, the LED pins, what will happen? It will draw more current. We are sourcing from the port pin. It should not be like that. So what we have to do? We have to use driver circuit for this also. Fine. But unfortunately, this simulator, we no need to use the driver. It is assuming the driver is inbuilt. Fine. You search it in Google for real-time connections. Fine. Okay. Now what we are going to see is we have to turn on all the LED. That is the first thing we are going to do. So we are using column cathode, row anode. That means we have to write 1s to the row and the 0s to the column. That's it. Fine. If I want to display a number 0, what I have to do? Wait a minute. So now I want to display the number 0. Later point we will go with it. Now we will turn on all the LEDs in the 8x8 dot matrix. First point. Fine. So now I am going to present the entire screen. Please wait for a moment. Most probably you will finish dot matrix display also by this class. Okay, I will share you one Excel file. You can use it for generating the patterns. Okay, it will be very helpful for you people. Manually, I will tell you how to do it, but I will provide you an Excel sheet, spreadsheet. Yes. Fine. Okay, now I am going to open the simulator software. So here what I am going to do is I am going to remove this. Yes. So here I have to give the naming as a minute. Yes, I have to naming it as row. Row is going to be P0. Take a minute, I will check for the problem statement. Rows connected to P0, column to P1. Yes, very good. Fine. So this line column I have to connect to P1. That's it. So initially I am simply going to do central not needed now. Okay, fine. Simply what I am going to do, I am going to enable all the LEDs in the dot matrix. I will give the connection, take the LED matrix. Please listen how I am writing the data. That's going to be very, very important. The first LED, I am going to take it as 7. Regarding the row, I am going to take it as 7. P 0.7, wait a minute, P 0.7. See, after I have written, I have choose the hardware configuration only, I can able to identify the data. Otherwise, it won't work. For the specified hardware only, you are writing the program. So entire port 0 we are connecting to the rows. Yes, 7, 6, 5, 4, 3, 2, 1, 0. Fine. So coming to port 1, it is connected to the column. Port 1 we are connecting to the column. Okay, as I am not using optical mouse, it's taking time. 7, 6, 5. See, like this only you have to test your devices. Before writing any program, you have to test your devices. That's very, very important. Some of your device may be damaged one the instant while you are purchasing itself. That we have to check it. Yes, okay, that's it. Okay, I have given the connection. Then coming to the settings, fade out interval, you just keep it larger as I told. Okay, then colors you can choose. Mapping. Okay, so here I am going to use random only. Row means it will automatically scan the row. You have to write the data only. Fine. Column means automatically it will scan the column. You have to write the data only. Fine. Here I am going to do both. Then color we have to choose red color. When the light will get low, row equal to 1 and column equal to 0. Yes, because we are using column cathode, row anode. Fine. Why they are keeping like this? I have told you now when you are going for driver IC, both should be 1. Okay. For example, previously we have did 1 to enable the digit, 1 to enable the segment. Yes. If you want, you can choose this. Like this, you can choose. Now I am choosing 1 0. Column 0, row 1. So that LED will glow. All fade out is if you just click on it, whatever the content it is displaying, it will clear for a moment. That's it. Okay. So now we can write the program. So in the row, we are writing the data as 0xFF. In the column, we are going to write the data as, that's it. So now we can run this code. That's it. I have to turn on the right. Yes, is it working now? Yes, is it working now? All LEDs are glowing. Am I right? Yes. Am I audible in both cases? Yes, yes. Okay, thank you. Thank you, Dixon. Okay, now you people tell me, I have to turn on an LED in this array. Any one LED I have to turn on in this particular array. You people tell me. Yes, rows are mentioned A, B, C, D, E, F, G, H, and the columns are mentioned as 0 to 7. You people tell me which row and which column the LED I want to make it. Yes, kindly tell me. You people tell me. Yes, C and 6. C belongs to what? C belongs to P0.5. This pin only I have to make it as 1. All other pin must be 0. That means what? 0, 0, 1, 0, 0, 0, 0, 0. What about the data? What about the data we have to write in the row? Yes, suggest me. What about the data I have to write here? Row as told by Logus Nega, the row value is C. Yes, the row C, which belongs to P0.5. That means that particular bit must be 1. All others should be 0. Is it 0, 2 or 2, 0? Shivakumar? 0, 0, 1, 0, then 0, 0, 0, 0. What Shivakumar told is correct, but he changed the digits. Yes, very good. 20. What about column? Coming to column, Logus Nega told which column? 6th column. Yes, 6th column means what about the pin number we have connected? Wait a minute. Yes, what about the pin number we have connected? P1.1. That should be 0. All others should be 1. What about the data now? What about the data now? Yes, DF. Wait a minute, we'll check. Is it DF, Shivakumar? Again, you have changed the nibbles. The very first LED in the column connected to 7. What you have to put? You are doing well. Okay, you are doing well, but you have to correct one thing. DF, if you put, what will happen? Column 2 LED will glow. Correct? What we have to do actually? Yes, kindly respond. CF, no Shivakumar, kindly check and tell me. Anybody else? Yeah, on seeing this, you people can tell. See, 6 means this one. Row C, column 6. 6 means that particular pin should be 0. All other pin must be 1. What about the data? Except that bit P1.1, all should be no 40 Shivakumar. 6th pin, this must be, yes, very good, FD. Very good, FD. இது புரிஞ்சிக்கிறதுக்கு கொஞ்சம் கஷ்டப்படுறீங்க நீங்க. Fine. Now what will happen? OC column 6. This LED will glow. I have pointed with my arrow. Correct. So this LED will glow if I run this program. Wait a minute. Yes. Okay, I have to turn off. Is it now? Yes. C3. I mean row C, column 6. It's similar to 7 segment only. You are selecting the column and writing the data. That's it. Is it okay? Is it okay, students? Is it okay or not? Yes, fine. Okay. Now I will show you. I think it is available in my another laptop. Wait a minute. I will copy and do it. Okay. Meanwhile, I will display. For this, you people find the data pattern manually. Display the number 0. You have to write a coding. Yes. Next thing is you have to display the number from 0 to 9. And this program, first program we are going to work today. I mean, this is the next one. Probably you people will try. Okay. Or else tomorrow I will demonstrate how to do that. Fine. So we are having another 5 minutes. So within this time period, I can tell you how to form the patterns. Yes. Yes, to display the number 0, this pattern must be glowed. Correct? So kindly note down the data. Regarding the first column, the first LED is going to be MSB. The last LED at the bottom is going to be LSB. Correct? So kindly you people form the data for this. All LED in column must be turned off. That means when I am writing the row data, all column in this LED must get turned off. For this, the pattern is obviously 0x00, correct? 0x00. Kindly you people find the pattern for all those things. 0, 111, 1100. Like that, you kindly form the pattern for all the 8 column lines. Yes, here we are going to write the row data and column line. The meanwhile, what I am going to do is I am going to share the file available in my another laptop. Wait a minute. Kindly find out the pattern. Kindly find out the patterns and type in chat. 8 pattern I have to form. Fine. Coming to column 0 and 6, 7. Okay, column 0, 6, 7. Same data. 0x00 only. Fine. Regarding this particular column, column 1 and 2, 3, 4, 5. Column 1 and 5. It is going to have the same pattern. Fine. Column 2, 3, 4 will vary. Data pattern will vary. Kindly find out that. Yes. Meanwhile, I will share the data to this laptop. I will put that Excel file in the Google Classroom. You people can make use of it so that you can form data. Wait a minute. Yes. Have you find out the pattern? Kindly help me. I will share that Excel file in the Google Classroom also. Kindly you people make use of it. Wait a minute. We'll download that file. Once it got downloaded, I will show you. Okay. Have you people tried? Anybody answered? Why no one is responding? See, I have shown the pixels, how it should be displayed for 0, correct? You people can make use of it, na? Why you people are not doing? You have to form 8 patterns. Okay, 8 patterns. Yes. Whether it is understandable by you students or not, kindly reply so that I will help you out. ரொம்ப சிம்பிளான விஷயம் தான் கேட்குறோம், பட் ஆன்சர் பண்ண மாட்டீங்க. See the top. Okay, fine. I think Anthony Surya is replying. For C0 it is 0x00. Thank you, Anthony Surya. We will check your answer with that particular Excel. Okay, fine. Column C7, C. Okay, fine. 8A, C2, 8A. Okay, fine. Then 9, 2. Okay. So now I will open that Excel file. Wait a moment. See, I have created that particular file on my own. Okay. So that might be useful for you people. Yes. Yes. Now I want to display. Now I want to display 0. Am I right? See, this is the very challenging thing you are having. Coming to this dot matrix, you people have to form the data pattern, not like your 7-segment code. Wait a minute. I'm trying to have all the things in a single screen. Yes. Okay, fine. Okay, now I want to display 0. So for this, what I'm going to do is, wherever I am filling once, that position should glow. Correct? All other position must be turned off. At the end, we can create some smiley also. This is a standard pattern used in the LCD to display the numbers. I'm making use of it. Yes, this thing is clear. Okay, now I will go with your answers. Wait a minute. Go with your answer. Wait a moment. Okay, 7C, 8A, 9 to A2. Have you people typed in chat? 00, 7C, 8A, 9 to A2, 7C. Yes. Yes, 8A. Put the other things. 7C, Anthony Surya typed. Yes. Okay. How you have to make use of this particular Excel is, whatever the bit you want to display. Okay. You just put 1. This is for column cathode. Column anode means the reverse pattern you have to write. The reverse pattern you have to write. Fine. Is it clear to everyone? So I am going to copy the array. I am going to copy this array. So this array I am going to copy. So I am going to use an array. I'm going to put on it. Okay, fine. So here what I'm going to do is, I'm going to create an array. So double underscore code. You have the habit of mentioning code so that you can save RAM space. Const char. Won't change. Once I have declared, it won't change. Yes. So what I am going to give the name is 0. Simply I am giving 0 equal to that array value I am typing here. Yes, is it clear up to this? Is it clear up to this? Now what I have to do is, initially I have to make all the LEDs to turn off. So for that, what I have to do? Row I have to write with 0x00. The column I have to write with 0xFF. Okay. Now please kindly listen. I have to use one variable for looping. So char I. Now what I am going to do is, for I equal to 0, I less than 8, 0 to 7, correct? The count is from 0 to 7, I plus plus. The very first time what I have to do, I have to keep the row data. Yes. Then we have to enable the column 0, correct? So the row data is available in the array 0 array, correct? So what I am going to do is, row is equal to 0 of I. That's it. The very first data in the array will come now. Fine. Now regarding the column, what I have to do? Column equal to, what I have to do? Please carefully listen. 0x80, right shift I times that I am going to complement. Zero logic nalla rotate panna mudiyadhu. For example, now on the EF nu eludra. First time it should be 0, all other bit are 1, EF. When I am rotating right hand side, zeros will start entering. Yes, to avoid that, what I am doing, I am having the positive logic. So 1 must be at the MSB position, all other bit must be 0. I am rotating to n times and I am complementing and writing. That's it. If I do like this, I can make it in a loop. Now what I have to do? I have to turn off all the LEDs for a moment. Now I have to go for the next data pattern in the row. So this I have to do again and again. The program is clear? Kindly see and tell me. Yes, is the program is clear? If I run this program, you can able to see 0 displayed on the display. Yes, is it clear, or you people have any doubt? I'm just copying that 7 segment code and pasting into an array. Fine. What I have did, row equal to 0x00, column equal to 0xFF. This 2 line, I have made all the LEDs to turn off. That's it. Next, I am initializing a variable I for iteration. So I equal to 0 means the very first time it won't shift the column information. Yes, 0x80 is going to be complemented. It becomes EF. Yes. Shall I run the program now? Shall I run the program now? So with this, we will stop today's session. We will run the program now. Save. Debug this file only. Yes. I think I had made one mistake. Void main. Yes, here I forgot to put the semicolon. Okay, students. So here I forgot to put the semicolon. So in today's session, we have learned multiplex 7 segment display and dot matrix display, both devices. Yes. Now I am running the program. Please wait a while. Yes, you people can see the display. It's very dim, actually. Yes or no? But real hardware, you don't worry, you will get a proper output. Okay, fine. If it is not convenient for you people to see the like this, what you can do is, you can just invert and write the data so that can have some good appearance. The data what I am writing, taking from here, I am inverting and writing. That means what? Whichever LED I want to glow, it will not glow. Other portion, it will glow. So that is how I can do. If you complement and write the data, the display will be inverted. That's all. No, it's not working. I think I did some mistake. Wait a minute. Yes. Yes. Is it working now? Except the LED is what I want to glow. All other is glow. Is it clear now? If I choose green color, somehow you people can able to see. In color, I can go for green. Yes, clearly now. For simulation purpose, I am doing like this. So now you people can see clearly. Yes, that's it. Okay, students. Thank you. So now I am going to stop the recording. In today's session, we have learned dot matrix display, multiplex 7-second display, how we can able to program it. So with this, almost all devices are over. Fine. So still, what are the things we have to teach is we have to go for LCD. Fine. That is one thing. Then we have to go for serial port programming. Then timer with interrupt and the serial port with interrupt. Using interrupt concept, we have to create some time delay. Yes. So still we are having some 3 topics. Most probably we will finish it by 4 sessions. Maximum of 4 sessions. Okay. I don't know how many days it is going to continue. Fine. As of now, how much things it is possible to cover, I will cover. Okay. Most probably we will finish the value-added course, the entire syllabus in time. Okay. Thank you. So now I am going to stop the recording. Peoples, if you are having doubt, you can stay and ask. Otherwise, you can leave.